Good day everyone! Welcome to Project M Squared. Tara na at sabay-sabay tayong manood at matuto. To start this video lesson, let us identify our learning targets. First, at the end of this video, you shall be able to evaluate permutation of n objects taken R at a time. Secondly, solve word problems involving permutation. These learning targets are guided by the most essential learning competencies of illustrates the permutation of objects and solves problems involving permutations. To continue this video lesson, let us have a quick game. Let us play anagram. An anagram is a type of wordplay wherein the results of arranging the letters of word or phrase produce a new word or phrase by using the original letters exactly once. Find an anagram for the word listen. One of the anagrams we can make from the word listen is silent. This reminds us that in able for us to listen attentively, we must be silent. As you have seen, an arrangement can be applied to words and can also be applied in many other situations. In mathematics, arrangements correspond to the word permutation. A permutation of the set of objects is an ordered arrangement of the items or objects. This implies order of object is very important. Since you already know what is permutation, let us try to identify which of the following scenario illustrate permutation. You have 10 seconds to decide whether each scenario involves permutation or not. Number 1, creating PIN for ATM account. 10 seconds, start now. Time's up. This situation involves permutation because you cannot access your ATM account if the characters of your PIN is not input in order correctly. Suppose if you have PIN of 1234, you will not have access if you input 4321 or 2314. You should enter your PIN 1234 in order. Thus, this involves permutation. Situation number 2. Putting fruits into fruit salad mix. 10 seconds, start now. Time's up. This scenario does not involve permutation because any fruit can be put into fruit salad mix regardless of the order. Situation number 3. A team of 8 basketball players need to choose a captain and a co-captain. 10 seconds, start now. Time's up. This scenario involves permutation because there is a distinction of roles between captain and co-captain. This implies whoever is chosen first will be the captain and whoever chosen next will be the vice captain. Situation number 4. forming a committee member consisting of 3 people from a group of 25 people. 10 seconds start now. Time's up. The answer is not permutation. This scenario does not involve permutation because each member of the committee has equal role to perform, thus, the order of election of the member does not matter. Did you identify correctly which of those scenarios involve permutation? If so, you are now ready to solve for the number of permutations. For the continuation of our lesson, we will now move on how to solve for the number of permutations. Let's consider this scenario for example. The racing club organizes a race in which 3 cars, A, B, and C, are joined. The questions are, how many possible race results are there if there are no ties? Second, in how many ways can the first 2 positions be filled if there are no ties as well? By analyzing the given problem, we can tell that this scenario involves permutation. This involves permutation because order is important. The order determines first placer, second placer, and third placer. We can answer these questions by listing all the possible outcomes through a tree diagram, or by following the definition of number of permutations, which will be discussed later on. We already discussed how to illustrate tree diagram in the previous video. Suppose we have already illustrated the tree diagram as follows. We can see that there are 6 possible race results. Therefore, our answer in question number 1 is 6. In question number 2, we are just interested on how many possible ways can these 3 participating cars win the first 2 positions. It means we are not interested on who wins the third place. In this reason, we will omit the last column which represents the third place. Given the possible outcomes for the first 2 positions, we conclude that there are 6 possible ways as well for 3 participating racers to win the first and second place. Tree diagramming approach is effective in dealing with permutation problem just like this. But this is very tedious tasks, especially when there is a large number of participating racers. Thus, we will study how to solve for the number of permutations given definition of permutation n taken n and permutation of n taken r. The number of permutations of n taken n at a time is given by permutation of n taken n is equal to n multiplied by n minus 1 multiplied by n minus 2 times multiplied by 3 by 2 by 1. And that is the same as n factorial. Remember, n factorial is the product of all integers less than or equal to n. For example, 4 factorial is the same as 4 times 3 times 2 times 1, which is 24. Secondly, 5 factorial is the same as 5 times 4 times 3 times 2 times 1, which has a product of 120. While permutation of n taken or at a time is given by permutation of n taken or is equal to n factorial over the quantity of n minus or factorial, where or is less than n. Let us verify whether our answer in the previous problem is correct using these definitions. Question number 1. How many possible race results are there if there are no ties? Since the number of participating racers and the number of positions to fill in are equal, we use permutation of n taken n, and that is equal to n factorial. We let n is equal to 3. Then, permutation of 3 taken 3 is equal to 3 factorial, and that is by definition of permutation of n taken n. Then, by definition of n factorial, we know that 3 factorial is equal to 3 times 2 times 1. And we know that the product is equal to 6 by evaluation. Therefore, permutation of 3 taken 3 is equal to 6. And this answer is the same as the answer in our tree diagram. For question number 2, in how many ways can the first two positions be filled if there are no ties? Since there are 3 participating racers, we let n is equal to 3 and r is equal to 2 since there are only 2 positions to fill or 2 winners to announce. Then, by definition of permutation of n taken r, we know that this will become n factorial all over the quantity of n minus r factorial. Then, by substitution, this will become permutation of 3 taken 2, which is 3 factorial divided by the difference of 3 and 2 factorial. Then, by definition of n factorial, this will become 3 times 2 times 1 divided by 1 factorial, and this is the same as 3 times 2 times 1 divided by 1. We can cancel 1 in the numerator and the denominator since they are common factors. What remains is the product of 3 and 2, which is 6. Therefore, permutation of 3 taken 2 is equal to 6. And this answer is the same as our answer in the tree diagram. Having learned how to solve for the number of permutations given values of n and r, let's evaluate the following. Number 1, permutation of 7 taken 7. Number 2, permutation of 7 taken 3. Number 3, permutation of 8 taken 5. You can pause this video to answer these at your own pace. Let's now have the answers. In number 1, permutation of 7 taken 7, n is equal to r. Therefore, n is 7, r is equal to 7. By definition, permutation of n taken n is equal to n factorial. By substitution, it will become permutation of 7 taken 7, and that is equal to 7 factorial. Then, by definition of 7 factorial, that will become 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5,040. Let's have number 2. Permutation of 7 taken 3. Given n is equal to 7, r is equal to 3. By definition, permutation of 7 taken 3 is equal to 7 factorial divided by the quantity of 7 minus 3 factorial. By definition of n factorial, 7 factorial will become 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 factorial. Then it will become 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. Canceling all the common factors in the numerator and denominator, permutation of 7 taken 3 will become the product of 7, 6, and 5, which is 210. Therefore, permutation of 7 taken 3 is 210. Number 3, permutation of 8 taken 5. We know that n is equal to 8 and r is equal to 5. By definition of permutation of 8 taken 5, it will become 8 factorial divided by 8 minus 5 factorial. By definition of 8 factorial, we know it is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 8 minus 5 factorial is 3 factorial. But we know that the product of 3 times 2 times 1 is just the same as 3 factorial. So this 3 times 2 times 1 can be rewritten as 3 factorial. Then, we can cancel 3 factorial in the numerator as well as denominator. What remains is the product of 8, 7, 6, 5, 4. And that is 6,720. Therefore, permutation of 8 taken 5 is 6,720. Did you get all the answers correctly? If you are still confused how to solve for the number of permutations, let me teach you a trick to remember. I have here the complete solution of permutation of 7 taken 3. Let us take a look on the relation of r and the number of remaining factors after permutation of 7 taken 3 is simplified. What can you notice about the number of remaining factors after canceling the common factors in the numerator and denominator? The number of remaining factors is the same as the value of r, which is 3. So instead of evaluating permutation of 7 taken 3 as 7 factorial divided by 7 minus 3 factorial, you can just evaluate it as 7 multiplied by 6 multiplied by 5. Remember, or describes the number of integers less than or equal to n to be used as factors. And that is a trick to remember. To apply this trick, let's answer the next activity. Match the column of permutation to its corresponding equivalents. You can pause this video to answer this at your own pace. Let's now have the answers. Number 1, permutation of 10 taken 4 corresponds to letter E, that is 10 times 9 times 8 times 7. Number 2, permutation of 7 taken 2 corresponds to letter D, that is 7 times 6. Number 3, permutation of 10 taken 6 corresponds to letter A, that's 10 times 9 times 8 times 7 times 6 times 5. Number 4, permutation of 7 taken 4 corresponds to letter B, that is 7 times 6 times 5 times 4. And lastly, number 5, Permutation of 9 taken 7 corresponds to letter C. That's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Did you get all the answers correctly? That's great! For the last part of this video, let us have a word problem to solve. The Open Mind Band has 20 songs to perform in a concert. At the upcoming Battle of the Bands, they will play 2 songs. In how many different orders can they perform 2 of their songs? You can pause this video to answer these at your own pace. Let's now have the answer. The answer is 3,800 orders. After watching this video, you have learned to evaluate permutation of n objects taken r at a time and solve word problems involving permutation. Thank you for watching. Again, this is Sir JC reminding you, math is easy when you perceive it positively.